right. So when you finish Calculus 1, you should be able to answer these four things. What did you learn in calculus? And then you go, oh, we learn intermediate value theorem, we learn mean value theorem, we learn extreme value theorem, and then we learn fundamental theorem of calculus 1. And then the guy will say, oh, that's impressive. You know everything. So that's very, very important theme in calculus 1, right? Okay, I'm about to introduce intermediate value theorem, right? The four things are our goal, important goal in this course. Intermediate value theorem. This one you have to write down really carefully. So I'll give you time to write this one down. So you have to write this one down verbatim. Theorem 10, maybe not that one. Delete that one. But the title, yes. IVT. What's IVT? Intermediate value theorem. All right, often I abbreviate it like this in the homework. Let f be a continuous function on the closed interval. Pay attention, it is about the closed interval, right? Only works for closed interval. And without loss of generality, f of a is smaller than f of b. You plug in the n value to the function, the other n value to the function. One thing is less than the other. What they mean by without loss of generality is that, oh, what if fa is greater than fb, or fa is equal to fb? All this thing, once you understand this particular case, you will have no difficulty to understand the other cases. Now that's the hypothesis. What are the hypotheses? What are the conditions given? What condition is imposed on this function? Continuity, right? Continuity on what interval? A closed interval. Okay. And then the function value, one function value is slightly different. Then following happens. Every value of y that is in between this function value fa, fb, this n part, there is a value c. I want you to go ahead and underline there is part. There is a value c in that interval a to b such that function value is precisely the one that intermediate value you chose. Whoever go and chose anything intermediate value, that's intermediate value. There will be there will be input that matches that intermediate value. That's what it says. And go back to the underlined part and understand. It is saying that there is a value. It's called existence theorem. The statement itself doesn't tell you where it is. It just tells you there it is. And then mathematicians have tendency to separate it. But if you look at the explanation of this one, it tells you how to find it. So that's a very important part of this idea. So we learn that idea as well. Okay? So here's graphical interpretation of this statement, and then I'll give you physical motion interpretation. Here's the x-axis. Fair enough? And here's the y-axis, where y-axis is not very important, so I'm not drawing that. I hope that's okay. Here's A, here's B, correct? The function's continuous, and they're talking about FA and FAB. FA is over here, okay? Y equals FA. But FB must be higher, right? So it should be over somewhere there. Y equals FB, correct? Those are up to here, correct? But I didn't do anything about continuous part, right? But I'll do that later. And here is a horizontal line. The equation of this line is y equals that FA. That's the equation of this line. And here as well, not just the point. All the points in here has y coordinate FB. Okay? I'm going to make one change here. Instead of y, I'm going to change the y0, if that's all right. Go ahead and change that to y0. It distinguishes from the variable. This one is going to be y0 in there. Is that all right? Instead of y. So where is this y equals y0? Somewhere in between these two things, right? So I'm going to draw a red line arbitrary choice. It could be right here. It could be right there. Any choice. So it's going to be something in here. Is that okay? This is where y goes to. That's why I wanted to change that to y0. This is a line y equals y0. Fair enough? Okay. Here is the intuitive part all the way up to here. Even though it is a sketch of a very special case, specific case, I think it has much generality in there. The following part is intuitive. I'm going to interpret this continuity here. It's very intuitive, not the mathematical definition, local continuity, global continuity, not that. It is just like drawing from here. You have to draw it continuously, right? You can't lift your pen. You started here, do crazy thing, try to avoid this red line, but you got to arrive it there, right? Come back in here. I had no choice to arrive it there because that's the function value. Continuously, you got to cross that red line, right? Correct? Once you cross that, what do you think that x coordinate of this one is? There's an English letter attached to this x coordinate there, according to the statement of this theorem. What it should be called? Anybody? This English letter, they named this one in here in the statement of the theorem. C, thank you. That is a C. X equals C. If you evaluate f of x, that arrives exactly y0. That is a pictorial interpretation of this theorem. A lot easier to understand, right? If you're on one side, an infinite plane, there's a border, you want to reach the next side, you can't fly, you got to cross that. You got to cross that border, correct? Physical interpretation usually goes like this. Suppose there is this path that you can up and down, and this is time axis. At t equals a, the object was here. At t equals b, object was there. And we assume this object moved continuously from here to there. It could do crazy thing up and down and go back and forth, but you should arrive it there eventually. And then you draw this position y equals y0, and then if it was here and arrived there at b second, if it moved continuously, you're guaranteed that it must have passed through that point. At some point it must have passed through that. That is the physical interpretation of intermediate value theorem. Is that okay? That is the intermediate value theorem. If you interpret it like this intuitively, it is really silly statement. Why do they call it a theorem? It seems like obvious statement, right? Why do they make a big deal out of it? Mathematicians' definition of continuity, it is different. How did mathematicians define continuity? They defined local continuity, right, using the limit. Then they went on to the global continuity, which is mathematicians' effort to capture intuitive idea of a continuity. If you have to abide by that mathematician's definition of continuity, establishing this obvious fact became tricky. So they have to do a lot of labor to make sense, to actually satisfy that mathematician's definition. However, we're not going to go into that proof, but we're going to focus on the idea. The idea is that I don't care about their eggs or not. How do you find it, right? That's usually people's interest, and we'll do that. Not on Tuesday. We're going to do it on Wednesday.